basic buffer is a solution that contains weak base and salt of weak base. Let us discuss some important points. First is pOH of a basic buffer solution is given by this expression. Kb denotes basicity constant of weak base. So once we know concentration of salt, concentration of base and Kv value, we can calculate pOH. pH can also be calculated because pH plus pOH is pKw. So pH is equals to pKw minus pOH. Now next important point we have, if concentration of salt is equal to concentration of base, in that case concentration of salt by concentration of base is equals to 1. So we can calculate pOH using this expression, and this value is 1. So we will have pKb plus log 1, and log 1 is 0. So pOH is simply pKb. So when concentration of salt and concentration of base are equal, pOH is equals to pKb. Now next important point, we can also write concentration of salt is equals to mole of salt divided by volume of solution. Let us say mole of salt is Ns and volume of solution is V. Similarly, concentration of base can be written as mole of base divided by volume of solution. Mole of base is Nb and volume of solution is V. So we can write this expression in terms of mole. Concentration of salt is mole of salt divided by volume. Concentration of base is mole of base divided by volume. So pOH is equals to pKb plus log moles of salt divided by moles of base. So this means in place of concentration we can also write moles. So ratio of concentration of salt by concentration of base is same as mole of salt divided by mole of base. Now next important point, that is dilution. Initially volume of solution is V. Now let us say this solution is diluted to eta times, that is final volume of solution is eta into V. So we can calculate pOH for final solution using the same expression, log of concentration of salt divided by concentration of base. Concentration of salt is mole of salt divided by new volume. Concentration of base is mole of base divided by new volume. So we will have same pH. So final solution has same pOH as the initial solution. We can also say pH is also same because pOH is nothing but pKw minus pOH. So we can say pOH of a buffer solution, and in this case basic buffer solution, does not changes upon dilution. So these are the property of a basic buffer solution. You will have same property for acidic buffer solution. Only thing is you will have this expression in terms of pH, that is pH is equals to pKa plus log of concentration of salt divided by concentration of acid, and everything will remain same, mathematics will remain same.